It's been a little while since I last gave an update on the basic implementation for the C256 Foenix. So I thought it would be a good idea to give a quick update here and show you some of the things that BASIC can do as of today. So for a simple demonstration, I'm going to display a sprite on the screen. I'll just go ahead and start typing in the program, and I'll try to explain it along the way. So one of the first things we need to do is to turn on the graphics and sprite engines in Viki. Viki is broken out into several different graphical blocks for the different things that it can do. Sprites, tiles, text, bitmap graphics, that sort of thing. They aren't all turned on all the time. Right at the start, only text, like right now, only text is turned on. So I need to turn on the graphics system and the sprite engine. And at the same time, I'm also going to turn on the text overlay mode so I can see what I'm typing as well as see the sprite at the same time. And I would just do that with this statement here. The address AF0000 is the master control register in the Viki chip, which has all those different bits. Now that I've turned that on, I want to fill out the sprite data. And what I'm going to do here is I'm going to just simply create a gradient effect for the sprite. Sprites in the C256 are 32 pixels by 32 pixels, and each pixel is using an indexed color lookup table system for coming up with a color. So each pixel is a single byte in memory, and that byte is referring to one of 256 colors that are defined in the active color lookup table. So what we're going to do is we're just going to loop through all of the different pixels, first by row, and then by column. And so you can see I have 4 loops here. And I'm going to poke into the cell for that particular pixel its row number. Now, all graphics data for the Viki chip is stored in the VRAM. VRAM starts at B00000 and goes up to some high number that I don't remember at the moment, but it's 4 megabytes worth of data on the current RevB board. And so I'm just picking this address of B10000 arbitrarily. Now, at this point, once this section has been run, we'll have turned on the graphics system, we will have put a gradient data into the sprite. And now we actually need to turn on the sprite and set up the sprite itself. So we have a whole bunch of additional pokes here. So there are several sprites that the system supports. I forget the number offhand. I think it's 8 or 16. And each one has got a section of registers associated with it inside Viki's address space. This is the control register for the first sprite, so I'm just going to poke a 1 in here and turn it on. Other things that this control register does is select which color lookup table to use and also indicate what layer of rendering the sprite is in, so you can bring it forward or push it back relative to other things. So I'm just going to turn that on and just leave the default settings for the rest. Now once I've done that, now I need to go in and tell Viki where I have put the pixel data for that sprite. That's that address B10000. I need to give Viki that address for the sprite. So there are a couple registers here to do that because we need to poke in 3 different bytes, low byte, medium byte, and then the bank number. To make this a little bit easier, I have added a new kind of poke statement, a poke W for poke wide. Regular poke only puts in an 8-bit value. Poke wide does a 16-bit value. So the address that we're going to be trying to put in is for this B10000. So the lower 16 bits are all 0, so I just poke that into this AF0201. And then I need to poke in the bank number. That goes into 0203. Now, Vicky only works with that video RAM that starts at B10000. But Vicky is assuming that that's where it's coming from. So when you're putting in an address into the Vicky registers, you don't give the address in absolute terms, you give it from the start of video RAM. So rather than poking in a B1 here, I'm just going to poke in a 1. Next, we need to give that sprite a location to be displayed in. So there are 2 registers for X and Y. They are 16-bit registers. So again, I will do a poke wide for those, just to make it a little easier. And I'm just going to put the sprite at 100 by 100. Now, if I were to run this program at this point, the sprite would display, and it would go to the 100 by 100 location. But the colors would be all wrong because we have not actually put in any color data. Whatever information is in the color lookup table for that sprite at this moment is what would get displayed. So I want to set up a gradient, so let's fill out that color data. So I'll do another loop, and I'm going to do colors 1 through 31. And the reason I'm doing 1 and not 0 is that color 0 is actually the transparency background color for sprites. So Vicky will not typically display any color if the index is 0. It will instead display whatever is behind the sprite at that location. So we don't need to set that color. Now I'm going to be doing a lot of pokes here, so I'm going to set up a little variable, which will be the address of the blue component for that particular color. And all that stuff starts at 240000 for the color lookup table that we're using. So that's the very first byte of the color lookup table. And I want a particular, for the Seath color, so to speak. And each color entry in the color lookup table has 4 bytes to it. 1 for red, 1 for green, 1 for blue, and then 1 for alpha. That is transparency or opacity. So to get the blue component for this particular color number, I am multiplying the color number by 4 and adding that to the base address of the color lookup table. Now I want to set the blue component for this particular color, and I'm going to start with intense blue, and I'm going to scale that down to nothing by the time we get to the end. So I'll start off with fully blue, and I'll subtract the color number times 8 to have it ramp down to 0 at the end. Now I want to poke in the red component, which is the green component rather, which is the very next thing. And I'm going to start at 0 and ramp that up to full green. The next component to add in is for the red, and I don't want any red in this at all, so I'm going to set that to 0. And then I'm going to come in here and set the alpha component. Here we go. Now, a couple things to note here. You probably saw me correcting things as I was typing. I've got a very rudimentary screen editor here where you can move the cursor around, you can edit a line. Let's say I want to put a space in here. I can put that space in, re-enter the line, all that kind of stuff. It's not full-featured yet. You can't insert stuff, but that'll get added in eventually. Other things to point out here is you've probably noticed I'm using hexadecimal numbers. For integer literals, this implementation of BASIC does support hexadecimal. And we're also supporting 32-bit integers here rather than just 16-bit, which is a little bit more traditional. Both of these things are put in so that we can more easily handle the addresses on the C256. Since the C256 has got a 24-bit address space and can support, I think it's something like 16 megabytes worth of addresses. Those, you get some pretty big numbers in there, so if you were typing this stuff in decimal, it'd get kind of tedious. So having the hexadecimals in there. You see we have peeks and pokes, we have our logical operators like OR, we have our for loops and all that kind of good stuff. So let me clear the screen here, and let's try running it. Oh, and I made a mistake. Good opportunity to show editing in place. That should be a U. You were probably laughing at me the whole time. All right, try that again. And there we go. There's our sprite. We can play around with that if we want. We can move it somewhere else if we don't like it being right there. Let's say I move it to over by 50, or I can move it up. Move it up a bit. You see we have text and graphics overlay with each other, all that sort of stuff. So there you have it, a quick little tour of some of the stuff that you can do in BASIC. There's a lot more stuff that's in here at the moment that I haven't shown, but I thought a little demonstration of the graphics subsystem and that BASIC is able to do this stuff and not crash would probably be interesting for people to see. I hope you found this interesting, if not enjoyable, and thanks for watching.